Hello friends, I welcome you to my YouTube channel MacPM. So this is our third video which is based on the numerical problems of fluid mechanics, and this is our second video based on the Newton's law of viscosity. So there is already a video before this based on the Newton's law of viscosity, so you can watch that video to understand it better. So we have two problems in this video. First there is one this problem, and another this problem is between viscosity between two rotating parts, and this one depicts the viscosity between two moving parts along a inclined plane. So let's solve the first problem first. So determine the intensity of shear of an oil having viscosity of 1 poise. So first of all, viscosity mu is given as 1 poise, which is equal to 1/10 Newton second per meter square. So this is given in the question. Now the oil is used for lubricating a clearance between a shaft of diameter 10 centimeter. So diameter of shaft is equal to 10 centimeter. If you convert it into meter, then it will be 10/100 is equal to 0.01 meter, and its journal bearing. The clearance is 1.5 mm. So this is a shaft and this is rotating here and bearing. So the clearance between these two is 1.5 mm. So suppose clearance is y. So y is equal to 1.5 mm, which is equal to 1.5 into 10 to the power minus 3 meter, because 1 meter is equal to 1000 mm, and the shaft rotates at 150 rpm. So n is equal to speed of shaft, which is equal to 150 rpm. Now from Newton's law of viscosity, we know that shear stress between two surfaces is equal to mu du upon dy. Here tau is shear stress, mu is viscosity, and du is change in the velocity, and dy is change in the distance between the two surfaces. Now in this problem, if we consider this rotating shaft one part, and then fixed journal second part, fixed bearing the second part, then you can see that if this one is rotating and another one is fixed one, so between these two there is a relative motion. Okay, so what is the velocity of this shaft? So you can see it is rotating 150 rpm at a speed of 150 rpm. Now if we calculate what is the perimeter of a circle, the shaft is circular, so if radius is r, then perimeter is 2 pi r. Okay, or if diameter is d, then it is pi d. So perimeter is pi d. So if it rotates, shaft rotates one cycle in 1 meter, then its speed will be pi d. So if it rotates once, then it covers distance of pi d. Suppose this is a particle on this shaft and it rotates one cycle, then it covers the distance of pi d. So it is rotating 150 times in a minute. So distance traveled by the particle is, or speed will be, pi d into 150, because it will rotate 150 times in a minute, and we have to find in second, because we have to find velocity in meter per second. So we will divide it by 60, because it is in minute, and 1 minute is equal to 60 seconds. So it will become pi dn by 60. You can also remember this formula, or you can calculate logically. So what will the velocity? Velocity will be pi, and diameter is 0.1 meter. Here you have seen already, into rpm is 150 divided by 60. Okay, so if you will calculate this, then you will get 0.785 meter per second. So this is the speed of this particle on the shaft, or speed of the shaft. Okay, so what else is unknown? If we want to use this formula, then tau shear stress we have to find, we have to find this value, and 1 point is equal to 1 by 10 Newton second per meter square already known, du is already known 0.785, and dy, what is the y? 1.5 mm, which is equal to 1.5 into 10 to the power minus 3 meter. So everything is known, so we will write tau is equal to mu du upon dy. What is the value of mu, which is viscosity? We have already seen the value of mu is 1 by 10 Newton second per meter square, into du is change in the velocity. So change in velocity between the rotating shaft and fixed journal. So fixed journal speed is 0 and rotating shaft velocity is 0.785, and this is 0, divided by change in speed. So what is the change in this? Divided by dy, change in distance. So what is the change in distance between the shaft and journal, which is 1.5 into 10 to the power minus 3 meter. So if you will calculate this, then you will find 52.33 Newton per meter square. So this is the shear stress between the rotating shaft and the journal. Now let's see the another problem, second problem. Here, calculate the dynamic viscosity of an oil which is used for lubrication. So we have to find viscosity mu, okay, between a square plate of size. So area is given as 0.8 meter into 0.8 meter, which is equal to 0.64 meter square, and the inclined plate, which angle of inclination is 30. So this is 30 degree. So if you make a triangle like this, then this is 90 degree, so this will be 60 degree. Okay, so shown in the figure, the weight of the square plate is 300 Newton. So weight W is equal to 300 Newton, and slide down the inclined plate with uniform velocity of u is velocity, which is 0.3 meter per second. The thickness of the film is this distance between plate and inclined surfaces, which is suppose y is equal to 1.5 mm. If we convert into meter, then 1.5 into 10 to the power minus 3 meter. Now we know that tau is equal to mu du by dy, which is Newton's law of viscosity. So here we have to find tau, we have to find mu. So this W is acting vertically. So if we find the component of W along the surface, along the direction of the movement of the plate, then it will become W cos 60. Force, suppose this component is force. So force is equal to W cos 60, which is equal to W by 2, because cos 60 is 1 by 2. So it will become 300 into 1 by 2, which will be 150. Now you know that force in the direction of the plate movement, the force is 150. So shear stress will be also shear force will be also in this direction. So this force will be equal to shear force. So tau is equal to force divided by area. Okay, so force is equal to 150 divided by area is 0.64 meter square. We have already calculated the area, which is given in the problem already. So it will become 150 divided by 0.64. If you calculate this, you will find 150 divided by 234.37 Newton per meter square. So this is the stress, shear stress. Now we have to find mu. So mu will be tau into dy divided by du, where dy is change in distance, which is equal to 1.5 mm. Change in distance between the plate and the inclined surface, which is 1.5 mm. So which will equal to tau is 234.37 into 1.5 into 10 to the power minus 3. This is already we have calculated, divided by du. Change in speed. Change in speed is between this inclined surface, which is fixed, and this is moving. So then the difference in speed between these two is 0.3 meter per second. So if you calculate this, then you will get 1.17 Newton second per meter square, or 11.7 poise. So this is the answer. I hope you understood this problem. If you have any doubt, then please ask.